Hey guys, let's talk about seasons. We sense the changing of the seasons, don't we? We can tell when the seasons are changing in various ways. A couple of ways would be, first of all, the number of hours that we experience daylight. It increases in the summertime, doesn't it? And in the wintertime, it significantly decreases. So that's one way. Another way that we sense the changing of the seasons, for those of us that have allergies, we sense them in the fact that we get allergies. We begin to sniffle and cough, and if you've got eczema, your skin begins to itch. So that's another way we sense it. Another way that we sense the changing of the seasons is in what we see, right? We start to see the roses bloom. My wife and I and daughter, during these Corona days, we've been taking long walks in the evening, in the early evening, and out at UOP, and wow, the beautiful roses, just so many, a vast array of colors. And the reason that we're seeing those is because of the changing of the seasons. Now, we sense the changing of the seasons, but what causes these changes? In other words, what causes the differences between spring, summer, fall, and winter? That's what I want to go over with you today, okay? Okay, so have you ever wondered why there are longer days and shorter days at various times throughout the year? That's part of what makes seasons what they are, right? Well, let's go over that. We know that Earth rotates once every 24 hours. Now, I have a Nike medicine ball here for exercise purposes, but I thought it would be good to use as an example or as a symbol of the Earth. So we all know that the Earth is a big sphere, right? And this particular medicine ball here has a line right here, as you can see. And that's really going to be handy because the Earth has what we call a line of axis. Okay, it's an imaginary line. It's the Earth's, what we call the Earth's axis. It doesn't really exist. But when we talk about the Earth and how it spins or rotates every 24 hours, okay, you can see a difference between the rotation of this ball if I tilt that axis, right? And then I rotate it like this, as opposed to if I don't tilt it and rotate it like this. See the difference? I'm going to tilt it and rotate it, and I'm going to put it back up straight and rotate it. There's a difference, right? Well, the Earth's axis or imaginary line right through the center and all the way through is tilted at 23.5 degrees. So the Earth's axis is approximately tilted at approximately this angle here. So as it rotates and as it turns and spins every 24 hours, it rotates upon that axis. So if the axis is here like this at 23.5 degrees, it turns like this all the way around until it gets back to facing the sun. You get the idea. It tilts on its axis at 23.5 degrees. Okay? So that's really important to know about that, the tilting of the Earth's axis, because it has everything to do with seasons, really. March 21st is when spring came around. That was a little under 2 weeks ago. And did you notice it didn't take that long before we really began to feel the changes, particularly in the temperature. Yesterday it was 85 degrees for a high. The day before it was 91 degrees for a high. Today it's going to be 85 degrees again. 2 weeks ago, I looked it up, 2 weeks ago, the high on this day was 74 degrees. Wow, a real significant difference in temperature change. So the seasons really, we experience the seasons, and the senses that we experience are real, right? Because we know, based upon our records of temperature, that seasons change the temperatures. Seasons, again, like I said, change what we see and how we feel. Okay, so spring comes around March 21st. Summer is June 21st. Fall, which some people call autumn, is September 22nd. And then winter is in December on the 22nd. Sorry, fall is September 23rd, and winter is December 22nd. All right. So what happens with the Earth in spring? Well, Earth's axis is tilted neither away from nor toward the sun. But let's start with summer, really. Let me put this away. Let's start with summer. In the summertime, starting around June 21st, you can see that the Earth, it's spinning around, and it spins around every 24 hours, 24 hours, 24 hours, 24 hours. How many times does it do that until it gets all the way back to June 21st? 365 times, right? That's 1 year, 365 days. But notice that its axis is tilted here at 23.5 degrees, or about that. And we are in the northern hemisphere, right? Let me grab this medicine ball again here. We are located in the northern, or top part, northern hemisphere of the Earth. Hemi means half, and half the Earth, there's below and above. We're in the top part, okay, the northern hemisphere of the Earth. Now, if we're in the northern hemisphere, let's say here, right here, notice that because the Earth is tilted and we are in the northern hemisphere, we are tilted toward the sun, okay? But we're not in the summertime, but we're not tilted directly toward the sun. In that case, we burn up, right? But we are tilted toward the sun, and because we're tilted toward the sun, we experience more heat. Not only do we experience more heat in the summertime, but what else do we experience more of? Well, also because of the Earth's tilt and the fact that the Earth spins around or rotates on its axis, we also experience more daylight than we do non-daylight or nighttime. So there's more daytime than there is nighttime in the summertime, okay? Well, we also not only do we rotate, but we go around, we make this path around the sun as well. What comes after summer? Fall. Now, if this is where we are in the northern hemisphere in the summertime, tilted toward the sun, that makes sense that we experience more heat and more daylight. When we get to fall, September 23rd, and this of course happens gradually, but by the time we get to fall on September 23rd, what's happening? We're not tilted toward the Earth, nor are we tilted away from the Earth in the northern hemisphere. What does that mean about our hours of daylight versus hours of night? It means that they're about the same, depending upon the date, right? So on September 23rd, guess what? The daylight hours and the night hours, darkness hours, are about the same, okay? So also, we don't experience as much direct sunlight. So the sunlight is becoming more indirect, and so that's why in the fall we don't experience as much heat. Now, let's continue on our path around the sun at a 23-degree angle and stop here on December 22nd, right before Christmas, right? 3 days before Christmas. What is it officially now? Winter. It's winter now. Now, again, remember, in the summer, we're on the northern hemisphere. Well, we're always on the northern hemisphere, but on the Earth's surface. But in the summer, because we're in the northern hemisphere, we're more directly experiencing that sunlight, which means more heat and more daylight hours. And then we get to fall, September 23rd. We've balanced out the number of hours in the evening and the hour of daylight versus the number of no daylight hours. When we get to winter, what's going on? What's happening is, because the Earth's tilt is such that it is, and we are on the northern hemisphere, what is true now about our direction or our relation to the sun in terms of placement. Well, now it's the opposite of what it was in the summer. In the summer, we were facing toward the sun, and in the winter, we're facing away from the sun. If you're facing away from the sun, that means you're getting less direct light, less direct heat. Okay? So less direct heat means, of course, that it's cooler. In the winter, we know it's cooler. And it's also true that we experience fewer daylight hours. Okay? And when you watch the video on this, even though this video that you're going to watch was made in the 1950s, they do a really good job of showing a model of these things. And so, you'll see the spinning earth, and you'll see why it's winter, and why we don't experience so much heat and light and all of that. So let's continue here and get to spring. Just like in fall, in springtime, we're not experiencing, let me restate that. Just like in the springtime, Earth's axis is tilted neither away from the sun nor toward the sun. We're sort of in the middle. What does that say about daylight? It says that the daylight and the non-daylight, or the evening time and dark hours, are about equal, just like in the fall. And it says that our weather is not as hot and not as cool as it was in the winter, and not as hot in the summer, not as cool in the winter, because why? We're not experiencing as much direct heat as in the summer, but a little bit more heat because of our angle than we were in the winter time. Okay, so when you watch this video again, it'll be clearer because you'll see the moving parts, right? And that's really important. All right. So, what are the reasons for direct heat being hotter than indirect heat? Because I've been referencing direct heat and indirect heat. Well, let's use the Nike ball again here and put it at a 23-degree angle. And let's say that the sun is over here and the sun's rays are coming at the earth this way. Well, the sun's rays are coming at the earth this way. At this point here, they're experiencing more sunlight and more direct heat than are we. Okay? So because the light is not as direct up here as it is here, the people on the northern hemisphere at this point around the sun, these people are not experiencing as much heat because the sun's rays are not as direct. And not only that, by not direct, I mean, if you've got a beam of light from the sun coming, a very wide beam coming in this direction, it's going to be very, very direct here, right? But up here, it's going to be more spread out. And because those rays are more spread out, in this case in the northern hemisphere, those people in the northern hemisphere don't experience as much heat, okay? Another reason why there is sometimes more direct and less direct heat is because of the Earth's atmosphere. We have around us this blanket, okay? And the Earth's atmosphere, we call it the atmosphere. And the Earth's atmosphere whisks away or pushes away or absorbs, some people like to say, absorbs some of that heat from the sun. And the more tilted you are away from the sun, the less direct, we talked about that, the less direct the rays, but also the more area there is for those rays to be absorbed by the Earth's atmosphere. And so those are the two main reasons why there is sometimes direct sunlight and heat and sometimes less direct sunlight and heat. And one more thing to say before we finish here. Not all places on the Earth's surface have the same seasons at the same time. Now in the video, the place that is referred to as opposed to the northern hemisphere, as opposed to California, say, or the United States as a whole, is Chile, okay? Because Chile is located in a different place on the Earth, let's say we're here and Chile is here, that means that when the sunlight is shining on this side of the Earth, Chile is going to experience less or more sunlight. And it will be significant too. The difference will be significant because northern and southern hemispheres are going to be different. So what does that mean? That means that during our summer, they're experiencing winter, and during their summer, we're experiencing winter. So it's springtime right here, right? In California and in the northern, in the United States, it's spring. But if you go to a different place on Earth in the southern hemisphere, they're not experiencing spring. They're experiencing a different season. Okay, so that's the last thing I wanted to cover on this. And that's all about seasons. Be sure you watch the video, the Ed Puzzle video that I posted. Be sure that you take a few notes so that when you take your test, you'll do well. Okay? Good luck, you guys.